All right, factoring special products. Our goal for today is I can factor special products. So remember when we multiplied the special cases, so we talked about different special cases. Remember we had difference of two squares, and we had perfect square trinomials. We talked about each of those when we were multiplying, and I told you remember them because we're going to see them again, and we're going to need to know how to factor them. So we have difference of squares and perfect square trinomials. So if we look at the first one, when we multiply, remember this 2 up here tells us that we have to write this thing twice, x plus 4 and x plus 4. Or if you remembered the pattern of x plus 4 quantity squared, you will be able to multiply it a little bit easier. If we didn't remember the pattern, remember we could FOIL this. So if we FOIL, our first terms is x squared. Our outside terms is 4 times x, which is plus 4x. Our inside is also plus 4x. And our last terms is 4 times 4, which is plus 16. If you combine your middle terms, we get 8x. So x squared plus 8x plus 16. This is called a perfect square trinomial because when we take the two numbers, the same, the binomial, and we square it, my first term and my last term are going to be perfect squares because you get x squared and you get 4 squared. 4 times 4 is 16. That makes it a perfect square trinomial because this is a perfect square, this is a perfect square. So perfect square trinomials, when we factor, we're going to be talking about undoing the multiplication, which is what we just did. We multiplied to get a perfect square trinomial. Next, we're going to take the perfect square trinomial, which is this, and we're going to factor it. We're going to undo it, and it's going to look like that. Okay? Same thing with number 2. If we were to multiply these out, or if you remember the pattern, and if you could see on the last one, there was a pattern. Okay, we would get 2 times 2 is 4x squared minus 6x plus 9. We get negative 12x in the middle, so we have 4x squared minus 12x plus 9. So when it's minus here, the middle term is always negative. When it's plus in the middle term is always positive. And the first and last terms are squared. All right, this is also called a perfect square trinomial. 4x squared is squared because 2 times 2 is 4, and 9 is 3 times 3, so that's a perfect square. And so we have a perfect square trinomial. So if I were to give you something like this and say to factor it, we would undo it, and it would look back to that. All right, number 3, this one is a little bit different. Because remember, when we multiply these together, what happens to the middle terms? Those middle terms, we have x squared minus 8x plus 8x minus 64. Those middle terms cancel, leaving us with x squared minus 64. This is what we call the difference of two squares. X squared is a perfect square and 64 is a perfect square. The difference, it's always minus. So we call that the difference of two perfect squares. So if I give you something that looks like this and I say factor it, I know automatically that since that's a perfect square and that's a perfect square, and it's the difference, that I'm going to get something like that when I factor. All right, and the same with number 4. It's going to end up with the difference of two squares because we have one positive and one negative. Both factors are exactly the same except opposite terms. So we're going to get 9x squared, and then minus 16. My middle terms are going to cancel. So this is the difference of two perfect squares. 9 is a perfect square, 16 is a perfect square, x squared is a perfect square. So it's a difference of all the perfect squares. When I factor it, we're going to factor it back to that. So that's what we're going to be learning today, is how to factor each of those special products. All right, special patterns in polynomials. We need to look for perfect squares when you use those patterns. So remember, these are all the perfect squares. We saw a couple of them above. Actually, that should say 64, not 68. Not sure how that happened. So 1 is a perfect square. Remember, 1 times 1. 4 is 2 times 2, and 3 times 3, and so on. And those are all perfect squares. So we need to recognize them and be able to see that those are perfect squares, so we can recognize the perfect square trinomials or the difference of two squares. The first one we're going to look at is the difference of two squares. So it's in the form a squared minus b squared. So the pattern, when we have that, a squared minus b squared, when we factor it, we're going to have one positive and one negative factor. And we're going to have an A and an A because that's my A squared, and a B and a B because that's my B squared. My middle terms would be, if I were to FOIL, my middle terms would be plus AB and minus AB, which are going to cancel, and that leaves me with the difference of two squares. So A squared minus B squared factors into A plus B and A minus B. If you recognize the pattern, then you don't really have to think much about it. You can just easily factor. So if I look at x squared minus 9, that's a perfect square. That's a perfect square because 3 times 3 is 9, and x times x is x squared. It's the difference, so I know I'm going to have two factors. It's the difference of two squares. Gives me two factors, one positive, one negative. My first terms are x and x. My last terms are 3 and 3. And my middle terms are going to cancel, which is going to be negative 3x and positive 3x. And therefore, x plus 3 and x minus 3 are the factors. Okay? All right. The next one we're going to look at is perfect square trinomial, when it's both positives, when they're the sum. When we have a perfect square trinomial, this is going to factor into a plus b quantity squared. So a plus b quantity squared. That is how it factors. Now you can factor this out. You could use your guess and check method to factor that out, and you're going to get a plus b and a plus b. But remember, a plus b is the same factor. So we want to write it like this, okay? I will probably take a half a point off if I see it looking like that, because it's important that you recognize the perfect square trinomials, okay? And know that they're written like that. So anytime you see it has exactly the same factor, just write it one time and square it, okay? So we don't want to write it like that. We want to write it with the quantity squared. So if I look here, okay, I know this is a perfect square trinomial because x squared is a perfect square. 9 is a perfect square. 3 times 3 gives me 9, but 3 plus 3 gives me 6. So I know that it's a perfect square trinomial because the same number multiplied by itself gives me 9, but added by itself gives me the middle term, which is 6. So when I factor this, it's going to be x plus 3 quantity squared. All right, perfect square trinomial, we're talking about the difference when the middle term is negative or minus. Okay, we're going to have the same thing, except this is going to be negative. So a minus b quantity squared. So if we look at this one, We know x times x is x squared. We know 3 times 3 is 9, or negative 3 times negative 3 is positive 9, but negative 3 plus negative 3 is negative 6. So it's a perfect square trinomial when both of my middle and my last terms use the same factor, but when multiplied it gives you 9, but added gives you 6, negative 6. So this is going to factor into x minus 3 quantity squared. Okay, hopefully you guys are starting to see the patterns on these. Start recognizing them. Check to see, is it a perfect square trinomial? If it's a perfect square trinomial, then it will factor easily, and you don't have to use the guess and check method. Okay. All right, factor each polynomial using the patterns above. Number 1, if we look at the pattern, okay, x squared is a pattern, is a perfect square because x times x. 16 is a perfect square because 4 times 4, but 4 plus 4, that does give me 8x, so I know it's a perfect square trinomial because the middle term is 4 plus 4. So we can factor this into, x plus 4 quantity squared. Quick and easy. I don't have to guess and check anything. Just look for your perfect squares. And make sure that the middle term is the same number but added together. Okay, doubled instead of a different number. Okay, it can be tricky because this one might be a perfect square, this one might be a perfect square, but the middle term may not be the multiple of or the C term. It may not be those added together to give you that middle term. So make sure that it's the same number added than it was multiplied. All right, number 2. X squared is x times x. Y squared is y times y. If we add x and y together, we're going to get negative 2xy. So y squared is negative y times y. All right, so this is going to give us x minus y quantity squared. And remember, we still have to consider, with this one we only really had to consider the C term, but remember, when we have a number up front, we also have to consider that number, whatever's in front, okay? So if we look at number 3, we still need to consider the number up front to give us the middle term. So 4 is 2 times 2, x is x times x, 9 is 3 times 3, okay? To get the middle term, remember, it's these two together. So this is negative and negative because we have a minus here. So negative 3 times negative 3. But then 2 times negative 3 is negative 6 plus negative 6. That gives me the negative 12 that I need for my middle term. We double it. So this is going to be 2x minus 3 quantity squared. And number 4, we have the difference of 2 squares. X squared is x and x. 36 is 6 times 6. It's the difference. So the difference is always going to be, it's the difference of 2 squares gives me 2 factors, one positive and one negative, because the middle term is always going to cancel. That's why we start with a binomial. So it's going to be x plus 6 and x minus 6. It doesn't matter if it's x minus 6 and x plus 6. It could be vice versa. I just always write the plus first. It's just my habit, but you can write it either way. All right, so that is factoring the polynomials using the patterns above, using the difference of 2 squares and the perfect square trinomials. The next thing we're going to look at is, first thing that we should always check for is, does it have a greatest common factor? Then we're going to check to see if it's a perfect square, okay? So let's take a look at the first one. What can I take out of each of those? Well, I know I can take a 3, I can take 1x, and I can take 1y. So if I take a 3, xy. I'm left with x squared minus, this is 4, I took an x out, y squared. Okay. This is the difference of two squares. So I have 3xy, and this is going to factor. So I'm going to have x and x, and this is 2 times 2 and y times y. So the difference of two squares is going to have two factors, one positive and one negative. That means I'm going to have x minus 2y and x plus 2y and x minus 2y. And so that is my answer for factoring. Okay, let's look at 6. Again, look for the greatest common factor. I know that I can take a 2 out of all of those. That's the biggest number that I can take. When I take a 2 out, I'm left with 9x squared plus 30x plus 25. All right, 9 is a perfect square. 25 is a perfect square. So this is 3 and 3. This is 5 and 5. If I multiply my 3 and my 5 together, that gives me 15. So 15 plus 15 is 30. And I know that's a perfect square trinomial because it works. So I'm going to factor. Keep your greatest common factor. Remember, that always has to stay to the left. Keep your greatest common factor. And I'm going to factor into 3x plus 5 quantity squared. So that factors into 2 times the quantity, 3x plus 5 quantity squared. And that's your final answer. Okay. 25x squared minus 1. Is that the difference of two squares? Well, 5 times 5 is 25. X times x is x squared. 1 times 1 is 1. So those are all perfect squares. 25 is a perfect square. 1 is a perfect square. Perfect square, the difference of two squares gets factored into two factors, one positive, one negative. This is going to be 5x plus 1 and 5x minus 1. So remember, when it has a 1, that's kind of always tricky because we don't really think of that as a perfect square. Okay, but remember, 1 times 1 is 1. That's still a perfect square. So those are going to factor. All right, number 8. It is the difference of two squares. 4 is 2 times 2, and x times x, and 25 is 5 times 5. Those are all perfect squares. Difference of two squares has two factors, one positive, one negative. This is going to be 2x and 5, and 2x minus 5. And then we're going to go down to the solving equation part with special products. No different. We're going to factor the same. We just have to set them equal to 0 and solve. So x squared minus 5, or minus 49, I don't know where I got 5 from. X squared minus 49 is the difference of two squares. They're going to factor into one positive and one negative. Set them equal to 0 and solve for x. So x plus 7 equal to 0, x minus 7 equal to 0, and we have x equals negative 7, x equals positive 7. So our roots are negative 7 and 7. Number 2, 4x squared minus 81. 4 is a perfect square, is 2 and 2, x and x. 81 is 9 and 9. Difference of two squares. So the difference of two squares is going to give me two factors, one positive and one negative. 2x plus 9, 2x minus 9. Set each factor equal to 0 and solve. So x equals negative 9 over 2, x equals positive 9 over 2. So the roots are negative 9 over 2 and positive 9 over 2. Okay, number 3. Remember, look for greatest common factor first. Does S have a greatest common factor? I'm going to assume because it has some bigger numbers that it probably is. So we can take a 3 out of both of those. When I take a 3, I'm left with 9x squared minus 4 is equal to 0. Well, we got to factor it again because 9 is a perfect square, which is 3 times 3. And 4 is also a perfect square, which is 2 times 2. So we're going to have 3. And the difference of two squares is two factors, one positive, one negative, 3x and 2, 3x minus 2. Set each factor equal to 0. And because 3 is the GCF and it doesn't have a variable, we don't really use it because we can't really solve for x. We just need to make sure we know that it's there and use it in part of our answer when we're factoring, but when we're solving, we don't really need it, okay? So when we solve, we're going to get x equals negative 2/3, and this is x equals positive 2/3. So the roots are negative 2/3 and positive 2/3. All right, number 4. Is this a perfect square trinomial? Well, this is x times x. This is 10 times 10, and then this is 10 plus 10. Yes, it's a perfect square trinomial because they all work. Therefore, I can factor this into x plus 10 quantity squared equals 0. Well, because x plus 10 is x plus 10 and x plus 10, I only need to solve one of those because we're going to get the same answer. So x plus 10 equals 0, x equals negative 10. There's only one root, x equal negative 10. Number 5. Remember, this always has to be 0, so we're going to have to add 64 to both sides and move it to the other side to get it there. X squared minus 16x plus 64 is equal to 0. Perfect square trinomial because this is x times x, this is 8 times 8, or negative 8 times negative 8, and negative 8 plus negative 8 is negative 16, so that is a perfect square trinomial. It's going to factor into x minus 8 quantity squared, and we get x minus 8 equals 0, so x equals 8. Okay, and then the last one, number 6. This has to equal 0, so we're going to subtract 64 from both sides. 25x squared minus 64 is equal to 0. Perfect square, perfect square. So we're going to have the difference of two squares gives us two factors. 5x minus 8, 5x plus 8, and then solve. So x equals 8 over 5, and x equals negative 8 over 5. So my roots are 8/5 and negative 8/5. All right, that is the lesson for today. Pretty easy. Should be able to pick up on all the patterns, and once you start seeing them more, you should be able to factor them pretty easily. You do have a quiz next class period, so make sure that when you're doing the homework, that is part of your quiz review also. So it's kind of mixed in, everything is mixed in as a quiz review for your quiz. We will go over the quiz review in detail before we take the quiz on Thursday. All right, hope you have a great day, and I will see you Thursday.